We are looking at some more U-substitution problems, and our next problem says the following. An oil storage tank ruptures at a time t equal to 0, and oil leaks from the tank at a rate of 100 e to the negative 0.02 t liters per minute. How much oil leaks out in liters during the first hour? So just as a reminder, when we are dealing with, or when we're talking about accumulated value, we are really just talking about the integral. So for this problem, we are simply looking for the integral from 0 to 60, so that's that first hour, of 100 e to the negative 0.02 t dt. All right, so just as a reminder, just recall that when we find the integral of e to the kt dx, we have a formula that says that this is equal to 1 over k times e to the kx plus c. You can use U-substitution here, but this is a form that shows up so often that we kind of formalized it for ourselves. So in this case, my k value is negative 0.02. So if I use this formula, I will see that this integral is equal to 1 over negative 0.02 times 100 e to the negative 0.02 t. And this is a definite integral, so we will evaluate from 0 to 60. All right. I'm going to just do one simplification. 100 divided by negative 0.02 is going to give me negative 5,000 e to the negative 0.02 t. And now we can use the fundamental theorem of calculus. Let's plug in top minus plug in bottom. Again, note that I leave any coefficients that's not necessarily part of the evaluation. I just leave them on the inside because it makes my calculation a little bit easier. All right. So when I evaluate this, I get negative 5,000 times e to the negative 1.2 minus, of course, e to the power 0 is just 1. And so this is equal to, equal sign, this is equal to negative 5,000 times 1 over e to the power 1.2 minus 1. So if you want to give an exact value, this is probably the closest exact value that you can give. Most likely you will give your answer as a number, even if it is an estimate. When I round to the nearest liter, I get 3,494 liters.